Okay, just a short lesson here to finish up section 1.4. We're going to look at being able to recognize and use the general form for a linear equation, or what sometimes is called standard form. And we're going to look at using intercepts to graph our lines. And then we'll look at some problems in the assignment with modeling data with linear functions and making predictions, looking at scatter plots. And that's something that we'll look at in class tomorrow, because that's something we're going to do with the calculators. Alright, so the general form of the equation of the line is this equation here. AX plus BY plus C equals 0. So we've got everything on one side equal to 0. We can't have A and B both being 0, and A, B, and C are just real numbers. So if we look at the first example, we want to find the slope and the y-intercept of a line with the equation 3x plus 2y minus 4 equals 0. Okay? So what we have to think about is what form do we have that gives us the slope and the y-intercept. And that form is the slope-intercept form. Okay? So what we really need to do here is take the equation that we have and put it into this slope-intercept form, which means we need to solve for y. Okay? So if we take our equation and we solve for y, we move everything but y to the opposite side. So we'd have 2y equals negative 3x plus 4, because we would have to subtract 3x and we would have to add 4 to get rid of them. And then we're going to divide every single piece by 2. So it becomes negative 3 halves x plus 2. So our slope is going to be negative 3 halves, and our y-intercept is going to be at the point 0, 2. Okay? So it's simply just taking the equation that we have in general form and solving for y, rearranging the terms to get it into that slope-intercept so that we can pick out those pieces of information. Okay? So go ahead and take a minute, pause the video, and try to do the same thing with example 2. Find the slope and the y-intercept of the line represented by this equation. Okay? So again, we need to get y by itself. So we're going to subtract the 3x and we're going to add the 12, which leaves us with 6y equals negative 3x plus 12. And now if we divide everything by 6, this becomes negative 1 half x plus 2. So our slope is negative 1 half, and our y-intercept is again at positive 2. Okay? Pretty simple, just rearranging the equation and again just solving for y to get it in that useful slope-intercept form. Okay? Now the last thing we want to look at here is graphing our lines using the intercepts. So when we talk about an x-intercept, remember for an x-intercept we know that the y value is going to be 0. And to find a y-intercept we know that the x value is going to be 0. So in example 3 we're going to graph this equation using intercepts. So we want to find the x-intercept. What that means that y is 0. So we're going to replace y with 0, and then we're going to solve for x. So we'd have 4x minus 6 is 0, so x is going to be 3 halves. To find the y-intercept, that means that the x portion is going to be 0. So 4 times 0 minus 3y minus 6 is 0, so that term's gone. And we'd have negative 3y equals 6, so y is going to be negative 2. So we know that our x-intercept is going to be at 3 halves 0. Our y-intercept is going to be at 0, negative 2. So if we sketch that graph, okay, we could just make a quick sketch. 1, 2, we know that 3 halves is going to be somewhere right in the middle. Okay, between 1 and 2. Our y-intercept is at 0, negative 2. And there's our line. Okay, so when you're graphing using intercepts, you put in 0 for the y to get the x-intercept, put in 0 for the x to get the y-intercept, plot those 2 points, and draw the line. Okay, so we'll do some more with this tomorrow in class, and we're also going to look at scatter plots and linear regressions, which is going to be some calculator work. So we'll see you then.